Friday the 13th.
Oh, it's actually playing right now?
Mm-hmm.
Okay, so, good morning. It's Friday the 13th. We're probably going to be learning about metric relations and triangles. And yeah, so don't forget to like and subscribe.
Thanks, Marty. So metric relations in a triangle. So what is this? I just kind of explained a little bit before, but metric relations in a triangle, they're a set of equations that are true only for a very specific type of triangle. Okay, that's the basic definition of what this is. So this very specific type of triangle looks like this. It's a right angle triangle. So I'm going to draw a right angle triangle. Okay, so it's a right angle triangle. There's my little box in the corner that shows me that it's a right angle triangle. It's a right angle triangle that has its altitude drawn. The altitude is a line that goes from the top corner down at a 90 degrees. So this is also a right angle. So what you actually end up with is a right angle triangle with another right angle triangle drawn inside of it. Let me just choose the dot. So you have a right angle triangle here. We draw the altitude down, okay? And that gives us another right angle down here. The first key thing for metric relations in a triangle, it's very important how we label the triangle. Okay? So the way that we are going to label the triangle, and the reason I asked for someone to give me their yellow book, is because the way they label it in the yellow book and the way they label it in the Visions book are different. And if it's labeled different, the equations change. So I'm going to label it the same way they do in the Visions book because that's the book we work from the most often. All right? It's going to be important, you're going to see when I give you the instructions on how we solve these metric relations, that you label your triangles in this exact way. Even if they give you some random XYZ labeling or whatever, you're just going to cross out the things and label it this way, and then you will be able to follow your equations. Okay? So the triangle needs to be labeled like this, ABC. Okay, so A, B, C. And then down here is D. Okay? In the Visions book, or in the yellow book, they go A, B, C, and they call this H. Okay? If you're looking at your yellow Math 3000 book, and you look at the way they label their triangles, and you look at their formulas, it works. They match up. But I think it's easiest if we follow this labeling. A, B, C, D. The key thing to recognize here is that your D is always on your line, so it's not on the corner. D isn't on one of the corners. All right? And B is always opposite of D. You see that? Okay? So D is not on one of the corners, not on one of the vertexes. And B is opposite of D. A and C could actually flip and it won't change anything. All right? But that's what I want you to recognize. A, B, C, D. Okay. So now I'm going to give you 4 formulas. And if you'd like me to sit down and spend half an hour explaining to you why these 4 formulas are true, I can do that. But I'm not going to do that here. Okay? Right now, and for most of you, simply me telling you that these formulas are true is enough. You don't care about the why. Right? Anybody care about the why?
No.
If you care about the why, I'd be happy to explain the why to you. I like the why because I'm a math nerd. But I'm not a math magician, no. Okay. So here are your 4 equations. Equation 1. The measure of AB, so the length of AB squared, equals the measure of AD times the measure of AC. That's your first equation. So if you look at what this is saying, it's saying that this length here, squared, is equal to the measure AD times the measure AC. Okay. Yes.
Is that times that?
The little x is times in this situation. So it's a little bit confusing, but yes, this is times.
You put a dot if you want.
If you would like, for sure. Yeah. We use times because there's no x's
Okay.
here, so it's not meant to be as confusing. So it's times. So measure of AB squared is measure of AD times measure of AC. This measure of is just the length, right? If this is 12 centimeters and this is 5 centimeters, that's what they're talking about. Okay. Second equation. The measure of BC squared equals the measure of CD times the measure of AC. So BC squared, CD, AC. These two are similar things here. One is this guy, one is this guy. So they're just kind of mirrors of each other. There's two other equations. Third one, measure of BD squared equals measure of AD times measure of CD. That's our third equation. So BD squared AD CD. Okay. And the fourth one is a little bit different because it doesn't have anything squared in it. It has actually four things. So measure of AC times measure BD equals measure of AB times measure of BC. So it has four things in it. So I can't reiterate it enough. I'll even put it down here with a little star. It's the worst star ever, but that's what it is. It's a star. These equations are only true with a properly labeled triangle. Okay, by properly labeled, I mean that it's the right angle with the altitude drawn, so right angle, A, B, C, D.
So if they're not showing the height, then you're not using this at all?
You may have to, in some very rare occasions, draw in the height to be able to use this. So if you were given a right angle triangle and you drew the height and you had some of these measurements, you could choose to use metric relations as one of the tools from your toolbox to solve.
Okay.
But I will say that 95% of the time, it's a very obvious metric relations question on the exam. If you look at the exam and you see a question that has a right angle triangle with the altitude drawn in it and they give you some measurements, very good chance you're going to have to use metric relations for at least part of the solving.
Okay.
Now, what other tool do you already have in your toolbox that you might be able to use with a question like this? Pythagorean theorem. Don't forget about the good old Pythagorean theorem. Okay? Because, especially on an exam, and I say that because on a test I might be a jerk and say, use metric relations to solve this triangle, which would mean I only want you to use metric relations because I want to test to see if you can use metric relations. But on an exam, as long as what you do is mathematically sound, as long as what you're doing is real math, it's not some fancy-dancy made-up, you got lucky thing, right? So, for instance, if you use Pythagorean theorem to find one of the measurements on here, I'm okay with that. Especially on a situational problem, and this always seems to come up as part of the situational problem at the end of the year. there's a chunk that needs to be solved with metric relations, but sometimes you can make it a heck of a lot easier if you use Pythagorean theorem once. Okay? And on the flip side, so on the opposite side of that, sometimes you need to use Pythagorean theorem first. And then you'll have enough measurements to solve using metric relations. So you can definitely use those two tools hand in hand. Is that alright? Don't forget about the things that you learned in grade 7 and 8 because they're still useful, they still work. I didn't make anything go away, I didn't make anything not true. Right? I'm just giving you more tools to add to your toolbox. Okay, so let's look for a second. I'm just going to make this a bunch smaller and leave it kind of up here in the corner. We should still be able to kind of see. All we need is the triangle with the equations. Everybody see the triangle with the equations there?
Yes.
Okay, cool. So I'll leave that there and we'll do a little quick example. So maybe I'll go here and I'm just going to write steps to solving. And it's not super, like I said, it looks kind of confusing. If you look at these equations, they don't look like the easiest things in the world, but they're nothing that's hard, right? You all know how to use the square button on your calculator. You all know how to multiply. You all know how to take the square root. If you can do those, divide, sorry, you have to divide too. So if you can multiply, divide, take the square root, and square things, you can use these 4 formulas. And anybody can look at a triangle that's labeled and say, okay, I have this and I have this and I want to find this. Okay. So the steps are fairly easy, but the first one is the most important. Can anybody guess what the first one is? Has to do with my little asterisk that's down here.
Times something.
No, a little asterisk down here. This one, what does it say?
Oh,
These equations are only true with a properly labeled triangle. So what do you think the first step is? Label the triangle. Okay. They're often going to give you a triangle that's not labeled this way. And it might be confusing. They might give you a triangle that's labeled, I don't know, A, B, C, D. Okay? Or they might use something completely different. They might use W, X, Y, Z. Or they might use P, Q, R, S. I don't know. It doesn't matter. Okay? Whatever they do, don't completely disregard it because they might give you measurements that you have to write in. Okay, but draw beside your little equations, your little labels, A, B, C, and D, so that you can use those later. So step 1, label your triangle correctly. Okay. Step 1 deserves a couple exclamation marks. Step 2, write down what you are given. I'll put in the same step and what you need to find. Find. It's not even a word. Find. And then step 3 is choose the appropriate equation. So those are the steps. That's the key to it. Okay. So here we go. I'm going to show you an example. Solve the following triangle. So I have this lovely triangle drawn. It's a 90-degree angle there. Has an altitude. It's another 90-degree angle. I know the following. I know that this measurement right here is 4. Okay, so I accidentally stopped recording, so there's some new stuff here that you need to see. So I filled out equation 3. I filled in that I knew BD was 8 and I knew AD was 4, and then I solved for my unknown, which was the measure of CD. And so I first squared my 8 to get 64. Then I divided both sides by 4, and I got that CD was equal to 16. So that's that right here. Okay. Now, the other piece that I was able to figure out was that AC is equal to 20, because I know AD is 4, and I know CD is 16, so AC is going to be 20. Okay, Garth, what's measure of AB?
AB?
Yep.
8.94.
Okay. And what's measure of BC?
17.89.
Any objections?
No. I object to that idea.
Okay, that's not an objection. This is what I would like you to do for homework. You'll probably be done before you leave this class. Okay. In your Math 3000 book,
That's the yellow one?
that's the yellow one, page 173 to 174, number 1.
The one question?
Yep, it just covers 2 pages.
Oh.